In this video, we're going to learn about scientific notation. Specifically, we're going to learn how to write large and small numbers in scientific notation. We're going to learn to convert scientific notation to standard notation and how to convert standard notation to scientific notation. So let's get started. Before we get into scientific notation, let's do a quick review of multiplying and dividing by 10. So question 1, if you were to include a decimal point when writing the number 24, where would it go? If you answered at the end of the number like this, then that would be correct. And we would usually put a 0 after the decimal point. There's usually no point in putting a decimal point if there's nothing after it. In this case, we're going to put a single 0. Question number 2. If we were to multiply that 24 by 10 and write the answer, including the decimal point, what would it look like? Well, it would look like this, 240.0, and we might include a 0 after that. We might not in this case. And then if you were to divide 24 by 10 and write the result, including the decimal point, which you would have to have, what would it look like? Well, it would be 2.4. Now, right now, I'm just showing you these numbers as if we all agree that that's what it would be. If you needed to check that, you could do it on your calculator. Let's go ahead and look at this a little bit more carefully. So if we take the initial 24 with the decimal point, and now we're going to multiply it by 10, let's move it over to the left and move the decimal point 1 over to the right so that we will get our 240. So you can see that when you multiply by 10, you're moving the decimal point to the right by 1 place. Okay? Now when you do division by 10, you're going to move the decimal point to the left. So this 24.0 or 24 decimal point will turn into a 2.4 when you move that decimal point 1 to the left. Okay, so basically when you multiply a number by 10, the number increases and the decimal point is moved to the right. When you divide a number by 10, the number decreases and the decimal point moves to the left. Now this is how it looks when you're multiplying numbers by 10. Let's look at what happens when we look at multiples of 10. I should say we look at exponents of 10. So in this table you see 5 exponents of the number 10. In the middle we have 10 to the 0 power. Going to the left we go 10 to the first power and then 10 to the second power. And going to the right we have 10 to the negative first power and 10 to the negative second power. If you look at the rows, in the first row you see the initial expression with the exponent. The second row you see an expansion of that expression. And the third row you see how you evaluate that into a specific number. So for instance, 10 squared is the same as 10 times 10, and that would be 100. 10 to the first is the same as just writing 10, and that would be 10, and so forth. And when you get to the negative exponents, if you remember the exponent rules, a negative exponent means you take the reciprocal of the base, which is now, instead of 10, will be 1 over 10, and you leave the power as a positive. In this case, a power of 1 would mean that 1 over 10 to the first power is the same as 1 over 10. And 1/10 can also be written in a decimal form as 0.1. When your exponent is negative 2, then you have 1 over 100. You keep the base, but you change it to a reciprocal, and you raise it to the second power, so there's 2 of them. You get 1 over 100, and that is the same as 0.01 or 1/100th. As you move to the right here, you're dividing by 10. And so every time you divide by 10, the exponent is coming down by 1, and the value is decreasing by a factor of 10. So every time you reduce the exponent of 10 by 1, the number gets divided by 10. Now if you go in the other direction, then every time you increase the exponent by 1, the number increases and it gets multiplied by 10. These are some helpful facts to know as we go into looking at scientific notation. Let's look at why we use scientific notation first. An ordinary quarter contains about 97 billion trillion atoms. That's a lot of atoms and a lot of zeros. The average size of an atom, however, is about 30 billionths of a centimeter across. Now you see how both these numbers are very large and have lots of zeros in them. Large meaning long. Actually, 30 billionths of a centimeter is very, very small, obviously. But when the length of these numbers in standard notation, which is basically what these are, they're written in standard notation, or let's just say they're written regular, okay? So these numbers are very awkward to work with. Imagine if you had to multiply the number of atoms in a quarter by, say, the weight of an atom, right? That would be another tiny number. And so figuring out how to work with these large and small numbers would be very cumbersome. So we use scientific notation as a shorthand way of writing such numbers and working with them. Now let's take a look at what scientific notation includes. Numbers written in scientific notation are written as two factors. One factor is a number between 1 and 10. The other factor is a power of 10. Let's take a look at an example. Here is a number 1.35 times 10 to the fifth. It's written in scientific notation. You can see the factor that is a number between 1 and 10, namely 1.35, and a power of 10, 10 to the fifth power. Now, if we wanted to write this in standard notation, we would want to multiply the 1.35 times 10 to the fifth. So what would that mean, actually? Now remember, if the exponent is positive, we are increasing the 1.35. And to do that, we're going to move the decimal to the right this many times, in this case 5 times. If this was a negative exponent, we'd be moving the decimal point to the left. So let's move it over to the right 5 times. And by the way, 10 to the fifth is 100,000, which is exactly what it sounds like. It's 10 times 10 times 10 times 10 times 10, just like we would do with an exponent. Well, to do that, we're simply going to move the decimal point to the right 5 places. And when we do that, you can see that the decimal point that was here is going to go 1, 2, 3, 4, 5 and end up here. And our answer is going to be 135,000. Okay? So that's how that works. Let's do another example. Write the number in standard notation. So the number is 2.7 times 10 to the negative third power. So what does this mean? We have 2.7 times 10 to the negative third power. What is 10 to the negative third power again? Well, if you remember, a negative exponent means that you take the reciprocal of the base is 10, and you keep the power of 3 as a positive. So this is 1 over 10 to the third, or 1 over 1,000. So you could say 1 over 1,000 or 1/1000th. Okay? Now in this presentation, they show you multiplying 2.7 by 1/1000th, and they say divide by the reciprocal. I would say multiply 2.7 by 1/1000th. When you do that, you're going to be basically moving the decimal point to the left by 3 places. So starting here, we're going to go to the left 1, 2, 3. Let's see what that looks like. There you go. The 2.7, the decimal point was here. It moves over 3 places, and now you've got 0.0027. So that is what this number is in standard notation. When you're writing numbers in scientific notation, remember that for numbers that are greater than or equal to 10, use a positive exponent. And for numbers that are less than 1, use a negative exponent. You also have the case of numbers that are between 1 and 10, in which case you're going to use a 0 exponent, because 10 to the 0 is 1, and so 5.63 would be the same as 5.63 times 10 to the 0 power. Now let's look at translating standard notation to scientific notation. So here's a number in standard notation, 0.00709. Now we need to move this decimal point to a place where this number looks like a number between 1 and 10. We will later add a power of 10 to make it represent the correct number, but just to make 0.00709 into a number between 1 and 10, we'd have to move the decimal point between the 7 and the 0 so that you would have 7.09. So you would move it from where it is to 1, 2, 3 spaces back. Okay? So now you have 7.09, but we know that this number isn't 7.09. 7.09 is much larger than this 0.00709. So to make sure that our scientific notation properly represents the number, we're going to have to put a power of 10 that is a negative power of 10 so that we can reduce the value by a factor of 1,000. Okay, so if we move the decimal point 3, then we have to write it as a negative 10 to the negative 3. Okay, so written in scientific notation, 0.00709 would look like this, 7.09 times 10 to the negative third. When you look at it this way, if you try to translate it back, in fact, I think there's a bullet here that shows that, if you move the decimal point back by 3 to the left, you're going to end up with your original number. So translating standard notation to scientific notation is a process of moving the decimal point to where the number will look like a number between 1 and 10, and then counting how many times you moved. If you moved to the right, you're going to use a negative exponent. If you move to the left, you're going to use a positive exponent. And at this point, we have learned how to translate standard notation to scientific notation, translate scientific notation to standard notation, and generally how standard notation works. So I'm going to end the video at this point, and in our next video, we'll talk more about how to compare numbers in scientific notation and how to combine them with mathematical operations like addition, subtraction, multiplication, and division. Thanks for watching.